Chapter 2, Kinetic Factors, Class Life Sciences. Part 3, Effect of the variation in the surface of contact between reactants. At the end of this session, students should be able to define the surface area of contact of a solid reactant, identify the effect of the variation in the surface area of contact between reactants on the rate of the reaction. Then the third factor, kinetic factor, the surface area of contact between reactants. First, what is the surface area of contact between reactants? Consider the reaction between reactant 1, which is a solid, and reactant 2, which is a liquid or aqueous solution. Only the particles on the surface of the cube, the solid reactant, are in direct contact with particles of reactant 2, which is the liquid or the aqueous. Then, only peripheral particles of 1 react with 2. The peripheral particles of reactant 1 are in direct contact, then they react with reactant 2 to give a product. While the internal particles, the particles inside the cube, which are not in direct contact with particles of reactant 2, they cannot react with reactant 2. Only the peripheral particles of reactant 1, the solid one. Then, the surface where a chemical reaction occurs between two reactants, one of them is solid, is called surface area of contact between reactants. Now, relation between the size of particles and the surface area. Let's calculate the surface area of a cube. We have a cube of side 4 centimeters. And if we divide this cube into 8 cubes, the same amount, but now the size of each small cube is 2 centimeters, we divide it to the half. Same amount, but the surface for the bigger cube or one piece, surface equal a surface of one face, which is side times side 4 times 4, times number of faces, which is 6, then equal 96 centimeters square. This is the surface, total surface of first cube. Now let's compare it with the surface of the 8 cubes. The surface of one small cube is the same side times number of faces equal 24 centimeters square, but we have 8 cubes, then the total surface is 24 times 8 equal 192 centimeters square. The same cube is divided into 8 small cubes. Now the surface becomes bigger. We increased the surface of one cube when we divide it into small cube. Then we can conclude that for the same mass or the same quantity, the surface area of a solid increases when the size of its particle decreases, and vice versa. That means what? If we have a chalk, the surface, one is powdered and the other is one piece, the surface area of powdered chalk is greater than that of one piece of chalk, because the particles in case of powdered is smaller than that in case of one piece. Now, what is the effect of variation in surface of contact on the rate of reaction. We will study the reaction between calcium carbonate and hydrochloric acid solution using different sizes of calcium carbonate, which is the salt reactant, and then we will deduce the effect of the surface of contact on the rate of the reaction. Procedure. The table below summarizes the conditions of the experiment. We have 3 beakers. In each beaker, we put the same volume of hydrochloric acid of same initial concentration. Then the initial concentration of H3O plus is not a kinetic factor. And we have same temperature, then the temperature is not a kinetic factor. And we put the same mass of calcium carbonate, but in beaker 1 in powdered state, in beaker 2 small size pieces, and in beaker 3 large size pieces. As we see the surface of contact between reactants in beaker 1 bigger than that in beaker 2, bigger than that in beaker 3, because the size of particles increases passing from beaker 1 to beaker 3. This video shows the experiment. Here we have powdered calcium carbonate of bigger size and bigger sizes of calcium carbonate pieces. We have in the 3 beaker same volume of hydrochloric acid of same initial concentration. Now we add the calcium carbonate of bigger size particles into the beaker 3. We observe the effervescence, but it is slow. We have slow reaction. During this reaction, we have release of CO2. Of smaller size particles, we have bigger effervescence. That means the reaction is faster than in beaker 3. And when we have powdered calcium carbonate, the effervescence is bigger, and we have a faster reaction than when the size of particles decreases. That means the surface of contact increases, the rate of the reaction increases. Observation. The effervescence bubbling, that means the release of CO2 in beaker 1 is bigger than that in beaker 2, bigger than that in beaker 3. Interpretation. The equation of the reaction between hydrochloric acid and calcium carbonate is CaCO3 calcium carbonate solid plus 2HCl gives CaCl2 plus H2O plus CO2 gas, which is the cause of the bubbling or effervescence. The release of CO2 causes the effervescence during the reaction. For the same interval of time, the effervescence in beaker 1 bigger than that in beaker 2, bigger than that in beaker 3, as we have observed. Then the volume of CO2 released in beaker 1 bigger than volume of CO2 released in beaker 2, bigger than volume of CO2 released in beaker 3. Therefore, rate of formation of CO2 in beaker 1 bigger than the rate of formation of CO2 in beaker 3, bigger than the rate of formation of CO2 in beaker 3. Why? The difference in between the 3 beakers or the 3 experiments is the surface of contact between reactants in beaker 1 when we have powdered calcium carbonate is bigger than that in beaker 2. We have small pieces of calcium carbonate is bigger also than that in beaker 3 when we have large pieces of calcium carbonate. Conclusion: when the surface of contact between reactants increases, the rate of the reaction increases, and vice versa. Then the surface of contact between reactants is a kinetic factor. Application 1. Consider the reaction between zinc and hydrochloric acid, HO plus Cl minus, of net equation Zn solid plus 2HO plus Zn2 plus H2 plus 2H2O. The two experiments represented in the table below are carried out where R0 represents the initial rate of the reaction in each experiment. We have two experiments, 1 and 2. In the two experiments, we have same volume of hydrochloric acid of same concentration, initial concentration 1 mole per liter, temperature 25 degrees, same mass of Zn, but in experiment 1 granules of zinc, while in beaker 2 or experiment 2 powdered zinc, then the surface of contact in beaker 2 bigger than that in beaker 1. Therefore, R02 should be bigger than R01 because when surface of contact between reactant increases, the rate of the reaction increases, since we have same initial concentration of HO plus and same temperature. Compare R01 to R02. Solution. By comparing experiment 1 to experiment 2, we have same initial concentration of HO plus, same temperature, but the surface of contact in experiment 2, where we have powdered zinc, bigger than the surface of contact between reactants in experiment 1, where we have granulated zinc. Then initial rate in experiment 2 bigger than initial rate of experiment 1, since the surface of contact between reactants is a kinetic factor. This is the end of part 3 of chapter 2, kinetic factors, the effect of variation in surface area of contact between reactants.